Welcome to the lecture on characteristics of a queuing system. So, this course modeling and simulation of discrete event system. So, queuing is one of the example of the events where the events take place in discrete manner, and we will have some introduction about the queuing system, what a queue is, what are the main characteristics of the queue and how it is formed. So, we will discuss in some detail in this lecture. So, the first thing is how a queue is formed. So, basically we come across a queue in our daily life. We go to any counter and we are in the queue if there are persons already standing there, and if there are no person standing, it means there is no queue. So, you are going directly to get the service. So, basically for formation of a queue you need the customer. The customer can be anyone, he may be a person, he may be a machine, he may be any entity which has to be served, and then there has to be a server. Server means the one who is giving the service. So, he is at the point from here he will be giving the service. So, there has to be a customer and there has to be a server, and then queue has a meaning. Now, why queue analysis is required? So, basically what we see that in our daily life, because the organization needs to give the service, and from every service it has to earn. People pay for the service they get. Now, the thing is that if the server is always free, means the organization has to pay free. So, that an organization cannot afford to do. So, the thing is that since people need service, people are in need of service, they have to go at the service counter. So, that is how a server is important. Now, depending upon the importance, you will have to spend time in the queue. So, if you feel that this work is very much important, you would like to spend more time in the queue. If you feel that the worth of spending time in the queue is not so high, then the importance of the that event, in that case you won't like to go to queue. So, you will see that without that your work is done. Now, there are certainly principles. If there are small queues, if there is queue and you have the details for suppose 5 minutes, 10 minutes, and there is simple arithmetic involved, you can do the analysis. But then in today's life this queue has become very important. You see that large queues are there. If there is competition in the market, people try to see that the customers should not wait for long. So, they will have to optimize. So, for that, and then there are many things, many parameters are involved which are basically not deterministic, they are probabilistic. So, many a times there is complex mathematics involved, complexities are there. So, this analysis requires the use of powerful computing devices, and that is how whenever we use these computing devices, we do the computations, we do the simulations. That is what the simulation is. So, whenever we do, so as we will see, if you have studied the operations research course or anything about queuing, you must be hearing or you must be knowing about different type of queues. So, in that basically there are lot of parameters, there are lot of conditions, and they need to be solved. So, as long it is simple, you can do it using normal mathematics, but then if it is complex, then you will have to go for simulation. So, queuing models provide the analyst with a powerful tool for designing and evaluating the performance of queuing system. So, you have different kind of models, and these models help you to understand and evaluate the performance of a queuing system. There are many ways by which a system may be evaluated in queue, like how much time a customer has to wait, on an average how many customers are coming and they are getting the service, or on an average how much one customer spends time in the system or in the queue. All these are the different performance measures that we will discuss later, and basically the models which we make, that is a tool for the analyst, so that he can work on it, he can think about it, and he can come to the conclusions, he can come with certain suggestions. Now, a trade off is involved while designing a queuing system. What is that trade off? So, as we discussed that when a queue is formed, there are two persons, one is customer, another is server. The customer feels always that whenever he should go, it should be minimum time for which he should wait. So, ideally he feels that whenever he goes into the queue, he should simply get the service, means there should no one ahead of him, he should get the service. Whereas, the server who is sitting, the server or the organization, they feel that for the whole duration there should be large number of queues, so that they see that there is complete utilization of the server, there is complete utilization of the machine, so that they can earn maximum, they can give more and more number of service and they can get large earnings. So, basically both are the extreme ends, and you will have to have a trade off, you will have to have a balance. The customer won't mind if he feels that he has to wait for suppose 5 minutes. If he has to wait for 5 minutes, or if he has to go for more than that, then he may leave. So, that will be a loss to the organization or the server. So, and the server will also see, so and in that case customer will see that okay, I can wait for some time. So, customer has to compromise little bit, whereas the server will also see that the queue, the person should not wait for more than certain time. So, that way there is a trade off, and then a queuing system is designed so that both party, the customer as well as the server or the organization, aspect of this organization itself, they do not suffer to the extreme extent. So, typical measures of system performance. So, what are the normal typical system performance measures? So, they include the server utilization. Server utilization means for what fraction of the time the server is utilized. So, this is one of the typical measures of system performance. Measures of system performance or output measures of performance are the ones for which we are interested to find the value. So, in the queue system, normally we find the server utilization, we find length of waiting lines, delays of customers, average number of customers in the queue, all that average number of customers in the system. These are the typical output performance measures in a queuing system. System performance is predicted as a function of input parameters, means we have to express the system performance and you have certain input parameters. Some of the things input parameters means those parameters which you are supplying, whose value you are giving. So, you are giving these values which are known to you, and you want to calculate certain things by which you will be able to design for a better system, better queue design, and so that it can result into good customer satisfaction as well as good output in terms of whatever it be for the company. So, the input parameters which we know normally, which we supply, is the arrival rate of customers. So, how the customers arrive, customers arrive, how many customers arrive in a certain time. So, that is arrival rate of customers. Service demand of customer, rate at which server works, then arrangement of servers. These things are the input parameters, like customer will serve at what rate, what will be normally the time in which the server will complete the service. So, that is service rate. So, similarly, how many servers are there? So, you have all these parameters in your hand initially. So, these are the input parameters. As we discussed that if you have simple queuing systems, the mathematical analysis can be done, and then you can get these output performance measures calculated. However, in normal cases the queuing system is a complex. Whenever you have the realistic system, it is not very simple. In simple system, you know, you may have a deterministic system where you just say that okay, the arrival will be at this and this time. So, if we have certain 10 customers, you know the time at which they will come, and also we know that when, I mean, for the nth customer what will be the service time required. If we know all that, then in that case the performance measures can be calculated easily. So, simple mathematics can do that, but in real case this is not the situation. In real case the system is complex. We do not know when the customer is going to come, we do not know what service time will be taken for a particular customer. Then there are randomness in many aspects. So, for that to take into account, simulation is required. So, because simulation is advised, because there are many aspects involved, there will be some deterministic part, there will be some random part, all these is to be taken into account. So, then since the system becomes complex, simulation is the advisable option and it is required. Characteristic of a queuing system. So, what are the characteristics of a queuing system? What are the key elements? As we discussed, the key elements of a queuing system, one is the customer. So, what is a customer? Customer is anything that arrives at a facility and requires service. I mean, like people, machines, trucks, emails, all that, these are the customers. Whichever whatever arrives and it requires service, emails are coming and they are required to be sent to somewhere by the server. Then machines are coming for repair. So, repair person has to repair the machine and then machine will go out. Truck will come, you have to load something and then it will go. So, these things are customers, people used in banks, post office, railway station, I mean ticket counters, everywhere. So, you have the persons, these are the customers. Similarly, you have server. Server is any source that provides the service, like the repair person, as we talked. If the machine is the customer, the repair person is the server. Retrieval machines, runways at airport, these are the server. If the airplane is the customer which is coming, the runway is the server. Server may be busy, server may be free. So, server has two status, it may be either busy or it may be not busy, it may be idle. So, that is customer and server. Then you have calling population. Calling population is population of potential customers, means the customer outside the system, outside the server, you have a server, you have the customer, and the customer has to come from outside. Now, whether it is finite or infinite. Finite means you have some population which is a finite number of population is there, and then infinite means there is no end to it, like in banks it is an infinite population customer. So, customer will be coming. So, there is certain changes, there are certain changes as far as other aspects is to be considered in the case of finite and infinite calling population. Now, what happens in the infinite population model? So, in finite population model, arrival rate is not affected by the number of customers who have left the calling population and joined the queue. Now, in case of infinite population model, the arrival rate will not be affected by the number of customers who have got the service or who, and then also that way it does not depend upon that, whereas in the case of finite population model, arrival rate will depend on the number of customers being served. So, as the number of customers being served is increasing, that will change this arrival rate. Okay. So, that is the difference between infinite population model and finite population model. We will discuss more about it. So, in infinite population, arrival process is usually characterized in terms of inter-arrival times of successive customers. So, as we see that when we deal with the infinite population model, the customers is coming at one time, second customer will be coming at some time, third customer will be coming at some other time. So, we talk about the time in between the arrivals. So, normally we talk about it. Then arrivals also occur in different way. So, that we will discuss. So, before that we were discussing about the finite population model. In the finite population model, arrival rate will depend on the number of customers being served and waiting. Like if you have a large machine which is to be served by a repair person, once he attends that, the arrival rate will be further 0. Or if you have a finite population, one person comes, certainly the arrival rate will change, whereas in that case it does not depend upon how many persons are being served or how many are waiting, because this is an infinite population. System capacity, that is a limit on the number of customers that may be in the waiting line or system. So, that is the system, how many system, whether it can accommodate, how much it can accommodate. So, that may be in the waiting. If you are putting a limit, so that is limited capacity. If you are not putting a limit, it is a unlimited capacity. Banks or so, they are unlimited capacity. Anyone can come and join, but in some cases you can fix how many can wait, how many can come and be in the queue. So, that is the limited capacity and unlimited capacity, like that is for the system capacity. So, we are talking about the arrival process in case of infinite population. Now, arrival may occur either at scheduled time or there may be random arrivals. So, we first discussed that arrivals normally in infinite population models, arrival process is characterized in terms of inter-arrival times of successive customers. So, A1, A2, A3, A1 will be from 0 to first customer, the time taken is A1, like from first to second it will be A2, like that. So, in those cases normally you characterize this arrival in terms of inter-arrival times of successive customers. Then arrivals may be either at scheduled time, just like in the cases of doctors, or there may be random arrivals. So, as we go to any clinic or the doctor, there we fix the time we tell that you have to arrive at that time. So, these are like the example of scheduled time arrivals, and sometimes it is very random. So, the random arrival, in that you have inter-arrival times, and normally they are characterized by a probability distribution. So, we have discussed in the last lectures about different types of probability distributions, and we have seen that inter-arrival times are basically represented by or characterized by some specific type of probability distribution functions. So, then it may also happen that sometimes the arrival may be a combination of some deterministic part and some variable part or random variable part. So, as we can say that at this time plus minus it may vary by certain time, or and that part is not fixed, that is a random process. So, this way arrival may be modeled. Arrival may be one at a time or in batches. So, that will be batch arrival, single arrival like that. Then the batch may be also of a fixed quantity, a fixed number, or it may also be random. So, again randomness may be clubbed with the batch strength. So, this kind of arrivals can be designed, and basically these are to be put in the routines. So, when you are simulating the queue, at that time you will have to keep all these things in mind, what kind of arrival you want to take. So, as we have discussed that in the case of random arrivals, Poisson process is used. We have discussed that you have the Poisson process which discusses about the random arrivals, where we talk about the number of arrivals in certain time interval. So, as we discussed that the time between the arrivals is exponentially distributed, whereas so that is with rate 1 by lambda, whereas in the Poisson process it is lambda t in that time. So, that way it is. So, for random arrivals normally we go for Poisson distribution, Poisson arrival process. You may have the scheduled arrival. Then there are cases when we can also assume or we see that at least one customer is always present. So, in some cases or the server is never idle, like in machine shop the number of workpiece which is waiting is too many. So, that has to go. So, these are the different kinds of arrivals. Now, in the case of finite population model, the customer will be assumed pending when the customer is outside the queuing system. So, when he is outside the queuing system, he will be assumed pending, because as the another customer will go, he may get the chance of going into the system. So, he is a basically member of potential calling population. So, these are the different aspects related to the arrival of the customers in queue. Now, we will discuss about the queue behavior. So, when a person joins the queue, he has certain actions till or waiting for the services to begin. No, any customer who is coming into the queue, he feels that he should get a service. So, the typical process is that the customer will come, he will have a queue, or he may not see the queue, he may directly go to the service, but in normal cases there will be a queue. So, he will have to come in the queue, and after some time spending in the queue, he will go to the counter. So, the time it goes on the counter and starts getting the service, his waiting time is over. So, he now he has to wait only for getting the service. Now, the thing is that there are many behavior of the customers because of which he does different actions, like there is a process known as balking. So, the balking is that tendency of the customer because of which he leaves the queue when he feels that the line is too long. So, maybe it depends upon the aspect, the way the person feels. He comes and sees the queue length to be more than certain limit, in that case he may go. That varies from person to person. So, once he comes without joining the queue, he goes in there, enters and sees that there is a queue and he leaves the system. He does not go into the queue. So, that is balking. Similarly, you have reneging. Reneging means the customer joins the queue and he will be there in the queue for some time, and then he assumes that the queue is moving very slowly. So, it will take large amount of time for him to go to the service counter and get the service. So, in that case, after being some time in the queue, he moves out of the queue and he goes out of the system. So, that is known as reneging. The another behavior of the customer or the action of the customer is related to changing of the line, from 1 to 2. So, many a times the customer is there in one queue and he looks at the other server. So, you have parallel servers and he feels that the adjacent server or any other server, the people are moving at a fast rate. So, he will be going from one queue to another queue. So, this behavior is known as jockeying. Now, as we know, you have the queuing parameters. Based on that, these phenomena may also be modeled. We can set a condition that if the queue length becomes so, there may be a case of balking, or if the service rate becomes very small, in that case there may be a case of reneging. And in the case of different servers, if you have different service times by the server, so at one point of time it may be so that in one of the queue, if it is taking more time, from there it may go to another queue. So, this also can be modeled. So, these are the queue behaviors. QDiscipline. The next point is QDiscipline. So, what is QDiscipline? It is the logical ordering of customers in a queue for deciding which of the customer to be chosen for service. So, there has to be certain discipline so that there is no chaos. As we discussed that any person who is coming for getting service, he feels that he should get the service first. In that case, there will be chaos, nobody wants to wait. So, how you have to decide who should go first at the service counter. So, for that there are many cases. You have first in first out, that is FIFO. It is also called general discipline. Normally whoever is coming first, he will get the opportunity to get the service first. So, he will be the first one to go out, the second person will go second. So, like that, this is the general discipline, that is FIFO it is known as. Many a times you have last in first out, many a times whatever is coming and then the service starts from the end. So, that is known as last in first out. Sampling, whenever we do, if we are putting the stocks in a dark room and then we are taking out, maybe then normally we choose the first one, that may be the last sample which has gone into it. Service in random order, that is SIRO. So, in random order anybody can be picked and he may get the service. So, that is known as service in random order. Then you have shortest processing time first. Many a times we see that which process is taking less time. So, normally we prioritize according to that. If we see that some of the process is taking less time, then we try to prioritize them. So, that is, so we are going to take that one first which has the shortest processing time, and then service according to priority. So, we are giving priority to certain type of customers. It happens maybe at the doctors or at many counters where you have the VIPs. So, we give service according to priority. There may be chances that some VIPs will come. So, we may have to go for PR. So, these are the different kinds of services QDiscipline which is normally followed in the case of Q. Service time and service mechanism. So, service time, as we discussed, it is also the sequence of independent and identically distributed random numbers. So, that is again following certain probability distribution, and there may be more number of server, or there may be one number of server, there may be infinite number of servers. And similarly, you have the queuing notation. So, we will discuss further in the next lecture about the queuing notations, the different performance measures. So, in queuing notation you have normally 6 parameters. We see the 5 one where ABC. So, this is one is arrival rate, second is B is service rate, C is number of servers, N is the system capacity, K is the calling population size. So, this way you have the queuing notation occurs. So, in the next lecture we will discuss about the queuing notations and the system performance measures in general. Thank you.